In the product team, we believe quality is everyone's responsibility. Everyone plays a part in making sure that the product we are releasing meets a certain level of quality. As a quality coach, I guide the teams on how to do this. And the types of things I do include helping to identify risks in new features that are being built. In consultation with the engineers, I define recommended practices on how to test, when to test, and where to test in our development processes. I also teach software engineers things like what is a good test, when should we modify or delete a test, or when should we automate a test. Other things I like to do include evaluating testing tools and deciding whether or not we need a new tool or whether we need to replace an existing tool because it doesn't quite meet our standards. I also like to teach people how to report a bug and advocate for certain bugs to be fixed because I know how much of a problem that bug is for our customers. I monitor bug reports and identify any weaknesses in our testing strategies. For example, if I notice a lot of bugs that are coming through with Safari, I'll go back and look at our automated tests or our manual testing and actually identify any areas where we can improve on testing within Safari. And of course, I like to test the products myself. I joined Squiz many years ago as a trainer for Matrix. I got to experience firsthand what it was like to use this product for the first time, and I saw how many different ways a user could actually use that product to achieve what they wanted to achieve. I lived through the pain of having to learn something new, as well as the joy of when it actually did work. This experience made me passionate about wanting to produce high quality products for our customers that meet their expectations. In today's world, people want things fast. However, if those things don't meet a certain level of quality and expectations, we are also very quick to toss it to the curb. That includes software. In the past, when someone has picked a solution for an area of their business, they tended to have to stick with it because it was too difficult and too expensive to switch out. These days, however, if a solution doesn't quite meet our expectations, we can very easily change as there are so many options on the market in all sorts of areas. If we release a new version of our product without making sure it meets a certain level of standards, and instead our customer finds the issues, the quality of our product will drop and they will be really quick to toss us out. We are humans, we make mistakes, which is okay, but we want to try and avoid our customers finding these issues. So to do this, we have to test. We also want to start our testing as early as possible within our software development lifecycle. The longer we leave testing in the development process, the more expensive it is to fix any issues that we might find. For example, say we're building a new feature in our product that solves a major problem that a customer is experiencing. We don't want to go through the development process and release it to our customer only to find out then that it doesn't quite meet their expectations. We want to learn as early as possible if we are on the right track and whether or not we need to make changes. The earlier we discover the issues, the easier they are to fix. There are two different areas within testing: automated testing and manual testing. Manual testing we are performing all the time. Everyone is using our products every day in some form, so it's constantly being checked. When we release a major feature, I will write a test plan on what we need to test, and everyone from the product manager to the designers to the software engineers will execute that test plan to make sure it works before we release it. For automated testing, our main focus is unit testing, UI testing, and end-to-end testing. Unit testing checks small sections of code. A product can have thousands of unit tests, but as these tests are small and target a specific area of code, they typically only take minutes to run. The software engineers within each team within Squiz are responsible for writing our unit tests for the features they are developing. UI testing, on the other hand, tests our interfaces. As these tests need to load in the product in the browser, they take longer to run compared to the unit tests. So to make sure we don't blow out the run times of these tests, we limit the scope to key paths through the product that we are testing, and we try not to cover things that our unit tests cover. End-to-end tests check the fully deployed and integrated system. As these types of tests are slower to run, we limit the scope to just the critical user journey through the product. We are checking that the core features that our users rely on within the product are working. And if one of these user journeys were to fail, we could potentially be blocking our user from being able to complete their job, which is not a great user experience. Other forms of automated tests that we do include are visual regression testing, where we compare a screenshot to what our current interface looks like to make sure it hasn't changed. Smoke tests, which are checks that are run on the product once it's been deployed into production. Basically think like where there's smoke, there's fire. If we run these tests and there is smoke coming from the system, then we have a problem somewhere. And our last kind of automated testing is performance testing, which checks that the product performs under a particular load. In short, our automated tests are basically running all the time. As a software engineer is working on a change, they're writing new tests or updating the current tests, which they run locally to make sure they pass. Once they have completed their work, they will merge it into the develop environment. During this process, all the tests are run to make sure that the new feature works within the existing system and we haven't introduced any regressions. Some tests may also run in a separate process overnight. These are not as critical as the one that's run during the merge process, but help give our engineers an extra boost of confidence that they need to know that the product is working as expected. And there are two major challenges we face. The first and most common challenge is that we have too many tests that take too long to run, and therefore the feedback loop is too slow. This means a software engineer could be spending hours waiting for tests to run to find out if they've broken anything in the system. This is not ideal when we want them to be able to move on to the next task. Also, if the tests end up being so slow and annoying to run, engineers won't run them. Again, not ideal, as we don't want to be releasing breaking parts of the product. To help this, we only include the important or critical tests in our release process. And we run all other tests outside of this process. For example, as our product supports multiple browsers, we run the tests on the most commonly used browsers within the release process, but run the tests again on all supported browsers in a job that's run overnight. That way, when we commit new features, we are confident that it will be working on the most common browsers, such as Chrome and Edge, but the next day, we're 100% confident that it works on all supported browsers. The other challenge that we face is intermittent or flaky tests. A flaky test is a test that fails sometimes without any reason, because we haven't made any changes to the code, data, or environment. A flaky test may not mean that we have a bug in the system, but it can cause us a lot of headaches. When you have a flaky test, trying to figure out what is wrong can feel a bit like you're trying to find a needle in a haystack. As frustrating as it can be to try and fix them, flaky tests shouldn't be ignored. If we didn't fix it, at some point, we may start to ignore the test. If we start ignoring one test, we could start ignoring real test failures, or the flaky test could actually be hiding a real issue with our product, and we could be releasing bugs into production. Another reason why we would fix a flaky test is that they can reduce an engineer's confidence in the actual tests themselves. And this is something we don't want as a quality team. If people stop trusting the system, they will instead become overly cautious and less confident when they're actually trying to develop new changes in the code, and development slows down. Further to that, not only will development slow down, but merging in a new feature or releasing a new version of the product will also slow down. For example, say our tests take about 13 minutes to run, but you have to run them 7 times because of that one flaky test. That's 91 minutes to run tests that should have taken only 13. The biggest thing that surprises me about my job is that I'm always learning. There isn't one day when I haven't learned something new, whether it be about the tech we are using or an area within the team such as security or SRE. There is always something to learn. The biggest lesson I've learned in my career as a quality coach and a software tester is probably don't be a gatekeeper. It's easy for teams to turn to the tester and ask, can we release the product? Or we will only release when you tell us it's good to go. But it shouldn't be left up to one person to make the decision. I'm a big advocate for it being a team decision. Quality is everyone's responsibility. If testing finds an issue, then the team decides whether or not they can actually release the product. Sometimes I can find an issue and I think it's a showstopper, but when I actually go and discuss it with the team and we look at the risks and assess the likelihood of a customer actually finding the issue, we decide that it's actually quite minor and we're safe to go. This is probably really easy. If you know me, you know that I'm a huge Buzz Lightyear fan and therefore Toy Story. All the Toy Story movies. Buzz is like a big part of my life where I have, so my desk is full of Buzz Lightyears and my car number plate actually contains the word Buzz.